Okay, this was a request to do a video for problems 6 and 7 on Chapter 2 homework. Alright, so problem 6. This says, this figure shows the velocity graph of a particle moving along the x-axis. Its initial position, it has an initial position of 2 meters at the beginning at t equals 0. So we need to keep that in mind. Alright, at t equals 3 seconds, what is the particle's position? Alright, at t equals 3 seconds, all we have to do is determine, how is position related to a velocity graph? It's the area of the velocity graph between the curve and the x-axis, or the t-axis in this case. So what's the area of this triangle? It's going to be 1/2 3 times 6. So that's going to be half of 18, which is 9. That's the displacement. If the initial position was 0, that would be the final position. But since the initial position is 2, then we have to just add that displacement to the initial position. So 9 plus 2 would be 11. Your numbers may be different than mine. For my numbers, it's 11, meters. At t equals 3 seconds, what is the particle's velocity? Well, this is a velocity graph, so all we have to do is think about, okay, what's the value or the height or the ordered pair for this function at 3 seconds? It's 0. The velocity is 0 meters per second at time equals 3. At t equals 3, what is the particle's acceleration? The acceleration is the slope of the velocity. Since this is a line, it's easy to figure out the slope. Just rise over run. So let's see, it's going to be 6 over 3. And it's negative. So that's going to be -2. -2 meters per second squared. Alright, and that is problem 6. Let's look at part number 7. To take off from the ground, an airplane must reach a sufficiently high speed. The velocity required for the takeoff velocity, depends on several factors, including the weight of the aircraft and the wind velocity. Okay, good background. Alright, part A. A plane accelerates from rest at a constant rate of 5 meters per second squared along a runway that is 1,800 meters long. Assume that the plane reaches the required takeoff velocity at the end of the runway. What is the time for takeoff needed to take off? Right, I'm going to need to get some room to work for that thing. Oh no, that's not what I wanted to do. Okay, so we have, and let's think about what we know. We know A is +5. Okay, and we're trying to find T. It says assume that the plane reaches the required takeoff velocity at the end of the runway, and the runway is 1,800 meters long, so that means the final position is 1,800 meters. That's something we know as well. So, alright, I'm going to get my kinematic equations going here, and this is kind of my way to turn the keys to start the engine. I start with A, and then I start doing antiderivatives to get the other equations. So A is 5, constant 5, so VF is the antiderivative of that, which is 5t, plus initial velocity, which we can assume to be 0. And position is the antiderivative of this velocity, so it's 5t squared over 2. I'm just going to say 2.5t squared plus the initial position, which we can assume to be 0. All right, what do we know? We know this. We can plug that in for x sub f. 1800 equals 2.5 t squared, and we got it whipped. We can just solve for t by dividing by 2.5 and taking the square root. And t will equal, approximately equal, about 26.8 seconds. So let me go back and put that in. 26.8. It says use 3 significant figures, so I did use 3 significant figures. Okay. Part B, what is the speed of the plane as it takes off? Well, that shouldn't be too hard because we've already got the velocity equation that we need. And we know the time, so that's, yeah, we got it. Vf equals 5 times 26.8. Maybe I should use a few more digits. 8, 3, 2, 8. And only round at the end. So, let's just say times 5. And that is 134.16. 134.16. Alright, and let's go back and plug that in. Three significant figures. 134.2. Because no, just 134. Three significant figures would just be 134. Alright. Part C, what is the distance traveled by the plane in the first second of its run? Alright. All we got to do is say xf equals 2.5 times 1 squared. So that's going to be just 2.5. Simple enough. .5 meters. What is the distance traveled by the plane in the last second before taking off? Okay. The last second. Well, what I might need to do, there may be more than one way to do this. That you might think of maybe a better way than what I'm thinking of right now. But since I know that it takes 26.8 seconds to take off, then the last second will be between 25.8 seconds and 26.8 seconds. So I'm going to find the position when I plug in 25.8. And I'm also going to find the position when I plug in 26.8. And the difference between those is how far it traveled during that last second between those two times. So just doing a little calculator work here, 2.5 times 25.8 squared and 2.5 times 26.8 squared. All right. 2.5 times 25.8 squared is 1664.1. And if I change it to 26.8 squared, it's 1795.6. And the difference there, let's call this well, the change in x there is the difference which is going to be 131.5. So yeah, it went a lot farther in the last second of its takeoff than it did in the first second of its takeoff, and that's due to the fact that it's accelerating. It was going a faster velocity at the end than it was at the beginning. So 131.5 should be the answer. Three significant figures. So I'm going to say 132. I hope that's right. It may be 131. Yep, 132. Okay. What percentage of the takeoff velocity did the plane gain when it reached the midpoint of the runway? Okay, then the midpoint of the runway. Gotcha. Yeah, that's an interesting problem. All right. Okay. Let me get myself some room here. All right. The midpoint of the runway, if the runway is 1,800 meters, is 900 meters. So 900 is the final position in that case. And I can find the time that way. Just doing a little algebra. Okay. 900 divided by 2.5. And then taking the square root. I get 18.97. So plug that into VF. 5 times 18.97. And that will be 94.868. Okay, at the end of the runway, what was its velocity? Did we already answer that? I think it was 134. I thought we already answered that. I thought it was 134 point something. Let me just go back and remember if we already answered that. Yeah, we answered that in Part B. Part B, the final takeoff velocity was 134. So V takeoff was 134. So what does it ask? What percentage of the final takeoff velocity did it reach at the midpoint of the runway? So in other words, 94.868 is what percent of 134? So 94.868 divided by 134. I get 0.70797. So like, what does it want? 3 significant figures. No, let's see. It's best to the nearest percent. So that's about 71% then. 71, hopefully. That is correct. Good deal. And we've got an interesting explanation. This is a rule of thumb generally used by pilots. Since the takeoff velocity for a particular aircraft can be computed before the flight, the pilot can determine whether the plane will successfully take off before the end of the runway by verifying that the plane has gained 71% of the takeoff velocity by the time it reaches the halfway point of the runway. If it has not, the pilot knows there isn't enough time to reach the needed takeoff velocity, and he can abort the takeoff. Yeah. So that's how you do number 7. I hope this was helpful in helping you to complete and to understand those problems and Chapter 2 homework.